My name is Matti and I'm here to talk about the antenna integration. So the main question of the antenna integration is actually what comes out from the device. So what is actually coming out, the radiation outside from the device? Here is old mobile phone having an antenna upstairs. So if we look the picture here, so we have antenna on the top. Inside here is some matching components, transmission line and radio output matching. So typically it's designed so that the radio output is 50 ohm and the antenna is targeted to match to 50 ohm. In such a way you actually get the energy optimum transmission from radio to antenna and antenna hopefully radiates it out. The measurements you are typically doing is S11 measurement, which is actually measuring that how the energy goes to the interface and how much of that is actually reflecting back. The optimum is that everything goes to the antenna what you are feeding out, and then we have to remember that from antenna it actually have to radiate out. So the first optimization is really S11 reflection coefficient, that this radio output is matching to the antenna. One thing to remember is that both of these impedances, they are frequency depending. And then other thing to remember is that this is really only half of the story, because now we are looking only what goes to the antenna, but we don't know yet what comes out. The next measurement is really that passive antenna measurement. It's targeted to see that how the antenna is radiating out from here. So that is the passive antenna measurements, which is typical antenna design activity. And when you are combining both of these together, you are measuring total radiated power, so how easily the radio comes out. And total radiated power is frequency depending, and it's really needing a software enough to running the radio, and it's telling the total efficiency of the whole chain of the radio transmitting signal. So I have introduced you how the radio signal is starting from here, going over the transmission line and radiating from the antenna outside. In real device you always have some other components, including displays, cameras, keyboards, speakers, all kind of stuff which are affecting to the antenna. So basically what happens in the real life is that the assumed 50 ohm impedance in here is affected from all these different components you have inside the device. If you put the battery next to the antenna, it's already affecting to the antenna impedance. Actually, if you have a hand close to the antenna, it's also affecting to the antenna impedance. It means that the S11 result is changing all the time when you are changing the environment. And once again, S11 is telling how much energy is reflecting back. It's not yet telling that what is coming out. So it's really the over-the-air efficiency, what you can simulate, 3D simulation of the mechanical structures, having the antenna inside, and you get an idea that what is the actual power coming out and which direction from the device. In the simulation you need to model these different elements inside in certain level to get the proper answer. And when you are making the final design, you are able to make the measurement, and once again the measurement need to be done over the air to get the actual what comes out. To optimize this whole design process is really that the concept phase you already start making concept level simulation to figure out that what is the antenna type, antenna placement related to any other components inside the device. For the internal device or internal components effects, I have a picture here, simulation, 3D simulation of the electromagnetics. This is actually mobile phone type device, battery, PCBs. Here you can see antenna, which is intended to radiate out, but you can see in the picture that it's actually coupling very strongly on the other end of the device, where you have a camera here on the flex, and you can see that the energy you are putting out from the antenna is actually coupling back to the flex signal, flex level, flex PCB, and actually what happens is that the intended radiation out is very much reduced. We have had cases when this kind of coupled energy to the flex cable is connecting to the diode on the flex, which is causing that actually this flex is starting to radiate some unwanted signals out in such a level that you are failing the approval tests. So all kind of internal coupling is bad, and the best way to minimize them beforehand is the simulations, and then of course at the end you can make measurements and validate that you are really getting something wanted out from the antenna itself. So in this presentation you have seen that what happens when you have something inside the device changing the antenna behavior. In this picture I have bring in the surrounding like hand, table, metal. This will affect also to the antenna. It could happen on the mobile phone. If you put the hand up there, it's really different than you have the hand down there. It happens on the all kind of IoT devices, Wi-Fi devices, whatever radio devices you have, the surrounding has an effect to the antenna. It could be big or small depending on the case. Usually these kind of metal elements are very dramatic, but then some plastics might be more or less invisible. The surrounding is affecting in several different ways. When you change the surrounding, you're actually changing the antenna impedance, so it changes that how much this S11 is visible. And if you have very dramatic change on the surrounding, the impedance of the antenna is changing very dramatically, and it might happen that the radio cannot drive any more enough energy because there are so much mismatch. So you can affect to the radio performance through the bad antenna designing, and of course you are affecting to the antenna impedance, you are affecting the radiation pattern, efficiency, gain, and of course all kind of internal couplings are changing. I have seen the situation when the antenna is very much coupling back to the device when you have metal near to it. So these are the parameters you have to think beforehand. What is the use case? How to put the components inside the device in such a way that you get the safe antenna location, and then you can actually make the antenna designing matching to need what you have in the design. And finally comes the matching, which is fine-tuning everything in the end.